Modern backend development forces an immediate choice: optimizing for rapid execution speed today or building for scale years down the line. Building APIs often defaults to lightweight engines like Express or Fastify. These tools allow you to spin up a server in minutes, skip the heavy architectural rules, and structure the code exactly how you want. NestJS sits on the complete opposite end of the spectrum. It borrows its architecture directly from Angular, imposing a heavy, highly opinionated framework on the backend. Right out of the gate, it requires strict TypeScript. You have to write classes, you use decorators, and adhere to specific programming patterns. There is no opting out. Selecting this framework means committing your entire team to a specific, rigid workflow. It dictates how every developer on the project organizes their code. With a minimal framework, you can build a working API, complete with routes, validation, and database calls, entirely inside a single file. NestJS demands a much heavier baseline. Before writing business logic, you generate controllers, services, and modules across nested folders just to start the application. The appeal of that single file approach fades when a project grows. Without enforced boundaries, different developers introduce competing patterns, and the codebase quickly degrades into an unmanageable knot of logic. The core question is whether taking on a steep learning curve and writing hundreds of lines of initial boilerplate actually provides enough structural protection to justify the effort. The engineering trade-off here evaluates the immediate cost of architectural overhead against the promise of long-term, painless maintainability. To understand how NestJS maintains order, you have to look at dependency injection. It is the mandatory, foundational pattern driving the entire framework. Instead of writing a route handler that does everything, a single endpoint is split across 3 distinct layers. The controller strictly manages incoming HTTP requests and responses. All of the actual business logic, like calculating totals or checking inventory, is isolated inside the service. Finally, the module acts as the packaging layer. The framework uses the injectable decorator to automatically wire these pieces together, meaning components can share data without hard-coding their connections. In an unopinionated setup, routing, validation, and database queries are frequently crammed into a single sequential function. This strict separation creates a very real developer tax. Standing up a feature requires writing multiple files and dealing with heavy verbosity at the start. That upfront friction enforces domain-driven design. By locking code into specific boundaries, multiple developers can work simultaneously without causing systemic merge conflicts. Beyond file structure, the framework enforces a specific execution flow. Incoming data must pass through a rigid gauntlet before it ever touches your core logic. A client request hits middleware, passes through guards, hits interceptors, gets parsed by pipes, and only then reaches the controller, service, and repository. Guards execute early in this chain. They exist specifically to enforce authentication and authorization, blocking unauthorized requests far away from the database. Pipes handle strict input validation. They intercept the incoming payload, verify the data types, and transform it into structured data transfer objects. On the return trip, interceptors and exception filters catch the outgoing data. They map responses into a consistent format and catch errors globally so you never leak a stack trace to the user. This layered approach can be opaque. To beginners, this lifecycle feels like magic. When an error occurs deep in a pipe or an interceptor, debugging requires a deep understanding of the framework's internal timing. By forcing security and validation into these abstract layers, the core controller logic remains completely clean. Business rules are guaranteed to execute consistently across every endpoint. Enterprise applications always require repetitive integrations, connecting to databases, managing sessions, and handling identity. NestJS provides official wrappers for these tools. You use the Passport package for JWT issuance and the Type ORM package to manage your database tables. Relying on these wrappers means you are locked into the framework's specific configuration style. You lose the ability to write the direct, raw configurations that native Express allows. However, the framework's architecture offers a distinct advantage when it comes to raw compute performance. The core engine is platform agnostic. If the default Express engine becomes a bottleneck, developers can completely rip it out and replace it with the Fastify adapter. This swap drastically improves the maximum requests per second the server can handle. The trade-off is that you lose compatibility with older third-party Express middleware. The combination of official wrappers and swappable engines prioritizes standardized consistency and high-end performance over quick and dirty custom scripting. NestJS focuses on structural architecture. It provides a rigorous blueprint for organizing code that stays stable as the system expands. Deciding whether to adopt this tool requires looking at the realities of your team and timeline. Start by asking, what is the primary constraint of the project? Path A represents the solo developer, the indie hacker, or the early-stage startup racing to validate a minimum viable product. This path leads directly to lightweight APIs. When the goal is moving JSON rapidly to prove a concept, the heavy boilerplate and cognitive overhead of NestJS act as frustrating obstacles. Path B represents enterprise environments, massive applications or systems dealing with distinct business domains. This path leads directly to NestJS. The strict rules and dependency injection are necessary mechanisms to stop technical debt from accumulating as the engineering team expands. There is also a distinct advantage for teams already using Angular on the front end. The shared syntax and architectural patterns reduce the learning curve for developers crossing to the back end. Choosing the wrong tool carries heavy consequences. You will either suffocate early development speed under unnecessary abstractions or trigger a massive rewrite when an unstructured API collapses. If a codebase requires an enterprise-grade blueprint to survive multiple developers and years of iterations, NestJS provides the exact structure to keep the system intact.
Enhance your coding skills with us. Don't forget to subscribe to Code 5 Food for the latest updates and tutorials.